problem, we are asked which of the following key features are true for the quadratic function modeled in the table. The first option is the second difference of 4. So let's go ahead and find our first and second difference. So this would be -6, -2, +2, +6. And -6 to -4 is +4, -2 to 2 is +4, and 2 to 6 is +4. So this item is true. All right, let's take a look. Vertex is a maximum at -3, 0. So I agree that our vertex is at -3, 0 because that is a turning point. You can see we have symmetry 8, 2, 0, 0, 2, 8. There's symmetry on both sides of that vertex, but 0 is not the largest value. It's not a maximum in this case. It is a minimum. So this one is not a true statement. The axis of symmetry statement is not true. The x value at our vertex is -3, not 0. The statement of y-intercept none is not true. This quadratic function has a domain of all real numbers, and it will cross the y-axis. Just because it's not shown in the table does not mean that it will not continue to cross the y-axis. We could actually extend our table one more step to calculate the y-intercept. So let's see here. We could go do another first difference. So this would have to be +10 to give me a second difference of +4. And 8 + 10 would be 18. So this has a y-intercept at 0, 18. Okay, our x-intercepts. The x-intercept is at -3, 0, and since that's our vertex and the minimum, it is the only x-intercept, so this is a true statement. The domain of this quadratic is -infinity to infinity, or all real numbers. Our range is not y is less than or equal to 0. -3, 0 is a minimum, so our range is y is greater than or equal to 0. Let's check our symmetry. So if we visualize this parabola, -5, 8, -4, 2, -3, 0, -2, 2, -1, 8, we can see that this parabola, just in a very basic sketch, does not have symmetry about the y-axis, and I could not rotate it 180 degrees in order to map it onto itself. So it doesn't have neither even nor odd symmetry. So this is not true. All right, our end behavior is as x approaches infinity, y approaches infinity, and as x approaches -infinity, y approaches infinity. Looking at our sketch, you can see that this is the correct end behavior because both of our arrows are going up. So this is a true statement. Okay, let's take a look at our increasing and decreasing intervals based on our sketch. So our increasing interval is x is less than -3. So if I go to the left of -3, that is decreasing, not increasing. So the statement for the decreasing interval is true.